The last question that students sometimes have trouble with is question 10. It's mostly maybe because they get concerned about, do I have to know this code? You don't. And remember, you can look up stuff. And we are, and remember the control find or command find if you're on Mac, those are your friends. You use them all the time. And so if you didn't know about that, that's like a main thing that you're learning in this class is to do a find, because who wants to be like looking for information on the screen? That should help you. So let me show you question 5 so that you see you're not too scared of it. Okay, for question 5, I'm asking you, what's the 10 residue? So the first question here is like, what is a residue? And a residue is the same word as amino acid. It's an amino acid when it's in protein. So let me go up, look at the sequence. So over here, this guy's, the M is a methionine, that's an amino acid. N is an asparagine, that's an amino acid. And then their sequence or their structures are in this table. And they're all different. You could think about a protein as a necklace of beads, and it's a combination of these different beads, right? And they have different characteristics. You could think about the charges that one amino acid will attract or repel the other. So it's a very interesting necklace, as you'll see that there are different structures it assumes. But the residues, as I mentioned here, when I say a 10 residue consensus, I just mean a string of 10 amino acids, and then the consensus sequence is where do they agree. And maybe they don't agree perfectly, but I just wanted to reinforce the idea of consensus. So when we're looking for a consensus sequence, we are doing an alignment and checking in which parts of this protein is there conservation of amino acids. And because they don't agree 100%, when we look at the alignment, we cannot find 10 residue consensus, meaning we cannot find 10 amino acids that agree in all the positions. So because we cannot find that, then when you write the sequence, then you would write an X if it's some unknown amino acid, meaning there's so much variation in that position that you just put an X on your consensus sequence. Z is if your amino acid represents either glutamic acid or glutamine. So if when you're writing the consensus, you should imagine that one spot of the sequence, some proteins have an E, some proteins have a Q. And when you're writing the consensus, you're like, I don't know which one to pick, E or Q. Do I just pick whichever appears the most often? Then the answer is like, no, don't do either E or Q, write Z instead. And you don't have to memorize this. Mainly this question is to show you how do we look at consensus? How do we find a consensus sequence in an alignment? And then if in that one position you have either aspartic acid or asparagine, so some sequences will have an N, other ones will have a D. They're very similar, not exactly the same. But then you wanted to show in your consensus sequence that it's either one of these two, then you write B. All right, how do we find the consensus sequence? Let me pull up the muscle alignment, because that's what I asked you to focus on. Okay, so on this screen of the muscle alignment, right now I'm looking at the phylogenetics tree, but we are going to look at the alignment. So click on the alignment tab. And all right, I'm looking for a stretch of 10 stars, or 10 things where they agree. So remember, well, this is the answer for a previous question. The star is where all the amino acids are the same. But there isn't a stretch of 10 stars. I just picked 10 because I wanted you to find, is there any part of these proteins, there's 7 proteins that we're comparing. Is there a stretch where they all agree? And let's see what's the longest stretch. So the way I look for the longest consensus sequence, I do a control find, and there might be other ways too. And then I'm just looking for stars. And then, okay, it doesn't allow me to go beyond that, but that means that this is the most stars in a sequence. And then when I said 10, I could have said fewer or more, but it's basically 10 surrounding these 4 stars here. So let's see, what if I started in here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe I'll change that to 11, 12, so then you know. And then you're like, okay, how do I write the consensus sequence? Well, this part here, it's exactly those letters, because it's always phenylalanine in that position. So you always have this F, G, L, R. So those are always conserved. And now over here, you have some serines and some prolines. Okay, there's a dot there. Then I don't know, when I have a serine and a proline on S or a P, what letter do I write? And then according to those rules that I just told you, you write X. So what that is saying is that there's some amino acid before this FGLR that there is some agreement, but it's not exactly the same. So you can't write just S or P, then you write letter X. And so let's see. Oh, maybe I should make this amino acid. How about all the way to this one? No, I'll exclude that because there are that also agrees in all of them. Okay, so in that question, I'm going to ask a stretch where they match, they more or less matching. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That way maybe it's easier to figure out where's the boundary. So that would be 13.